Hello, today we're going to be looking at this Sony DSR-11. It's a DVCAM recorder and player. It also takes small size tapes, so it'll run mini DV tapes as well. But in particular, we're going to be looking at the Firewire connector at the back. Now, that's an IEEE1394 connector technically, but in practice people call them Firewire because that's usually what they are used for. Now, the DV stream can go down these cables and go to a PC and will allow you to do a pure lossless digital transfer of the tape contents, including the time and date information. It's embedded in the video information. It's not burnt into the screen, it's embedded in the data. Now there are two sizes that are used typically with Firewire. There's this larger one which is 6-pin and a smaller one which is 4-pin. There's also 9-pin, but that's not really used in the Firewire sense as far as I'm aware. So typically you would plug one end here into your video device. In this case it's a Canopus ADVC55, and then the other end into a Firewire card in your PC. Actually, I do recommend PC over Mac, and maybe I'll explain why later. But for something that I use every day, I am deeply unhappy with this connector. These both ends, the small and large as I'm going to call them, the 4 and the 6-pin, are desperately flawed connectors, and when we work on this DSR-11 we'll find out why. Okay, let's do a short video capture onto a PC here from the tape that's in this machine. Let's switch on this DVCAM machine. It has a tape already in it. It's going to be detected by the PC, and we can import from Sony device using, in this case I'm using a version of Pinnacle Studio. Actually it's not a version I use terribly often, so bear with me if I'm a little crusty. Okay, so let's hit capture. It will start the machine up. You see it's gone into play and it's doing video capture now, and that is full lossless quality. So you'll finish up with a DV AVI file which has got the embedded time and date information if it was recorded on the tape, and that would be 13 gigabytes per hour. Lossless. Still interlaced, just like the tape. I kind of support the DV format. I think it's quite a good quality capture. I use it not only for DV tapes like this, which is of course lossless, but also for a lot of domestic formats such as VHS and Betamax and 8mm. I will capture to the same type of DV AVI files, albeit of course you don't get the time and date information on those. Now that'll generate loads of hate, okay, and I'll expect it in the comments, people saying, no, you shouldn't use that, there are better codecs. Yeah, sure, there may be better codecs, but I'm using these anyway, or something like this. And here we're in PAL land, and the DV codec looks better on PAL than it does on NTSC due to the way the chroma encoding is done on NTSC. So you can get really quite acceptable results from sort of VHS and Betamax and 8mm on a DV capture, and it maintains the interlacing. You can transfer it to smaller files, MPEG-4s and stuff later, but you finish up with a file that is acceptable by virtually all video editing software. There's one application that some versions of doesn't work with DV AVI files, and even in that case you can just turn them into DV MOV files and then it works, and there's no loss of quality. You just strip out the time and date information. So all so far so good, right? These 13 gigabyte files, 13 gigabyte per hour, is a sensible size ratio, I think, between quality and file size, and people can handle them. If they're using a Mac, they can use it with iMovie or Final Cut Pro or DaVinci Resolve. If you're on a PC, I think almost all software will handle DV AVI files. So it all looks like great stuff, but we're let down by these utterly ghastly connectors. Let me briefly tell you what's wrong with them, and then we're going to get stuck into fixing this video recorder. And you may say, it doesn't need fixing, it's working fine. Well, it isn't. Right, so this end, the 4-pin ones, it's a nasty connector to have that plugged into a little socket on the back of your machine. The stresses are too high, everything gets bent, and you finish up with an intermittent contact or the socket getting ripped off the board. This end is a lot more robust, but if the socket or plug, usually it's a socket, wears, you can get to the situation where it's possible to accidentally plug that in back to front. And this is where Firewire earns its name, perhaps, because you will blow up one or other end. So if you plug a machine like this, or camera, into a PC and you've got that back to front, you will fry the electronics in there, even if this is switched off at the time. So don't call it Firewire for nothing. And guess who's done that? My dear lady, Mrs. Video 99, she once upon a time, I'd asked to plug one of these in an old computer, and the socket was worn, and she plugged it in back to front and fried one of these and had to send it off for repair, which was quite annoying because it cost, this going back many years, it cost about £100 to get repaired. So it's a horrible connector. There are other difficulties too. You can run into problems over a long range. You can get switches for Firewire, and they degrade the signal a little bit more and make it even more unreliable. So it almost feels like Firewire, it's a wonder when it graces us with its presence and bothers to work at all. Right, this connector on the back of here works when it's kind of half plugged in. If I push it all the way in, I won't be able to capture anymore. So we've got an intermittent connector here, and you'll also hear people say you should never plug these in when the equipment's switched on. In some cases that's pretty much impossible to avoid, but there is a hazard when plugging them in live that you could blow something up, even if you can't necessarily avoid it in some cases. Right, let's briefly talk about this machine. This is a DSR-11. I've had this for many years, and at one point the socket on this, which had had a lot of use in its previous life, failed, and it was completely useless. So I fitted a replacement socket which I'd salvaged from an old broken camcorder, and that worked for many years. But now that's getting unreliable. It's either because the plug, or rather the socket, is not making good contact with the plug, or maybe it's poor contact with the board where I've tried to solder on a socket which wasn't really the correct one for this machine. So my plan is to inspect that and probably change the socket, and we have some brand new sockets here which I ordered some time ago. Let's have a look. So we have some sockets there, so I can hopefully fit one of those, I've only got two, I better not mess it up, onto the board. And you can have a difficulty, as I think I had on that one, that some sockets are one way round and some sockets are the other way round relative to the PCB. So that could cause some issues too. The other cosmetic issue we have with the DSR-11 is that the front panel falls off, and I have on occasions sort of rebuilt the hinges here with a bit of plastic welding to make it so that that will operate properly. But we'll tackle that little cosmetic issue later. The first thing we need to do is have a look at what state that socket's in and get on with replacing it. Right, here you can see my handiwork. I did this many years ago, probably 10 years ago or more, long before I had a YouTube channel. So I've had to mount the socket upside down, so I think here are where the tabs should be to fit this into the PCB, but we've had to go upside down, so I think I've used some desolder braid there to strap it down to the board, and we've got our connectors here, so there should be 4 of them. 1, 2, 3, 4. That's wobbly. I don't know if you can see that. That's going to be the reason it's not working, I suspect. That connector is not making contact with the board anymore. Probably because it was never long enough to reach. So I could just try and fix that, but I'm not going to. Let's have a look at the new sockets and see if they're better. So we need to make sure that, looking at this, that the socket has the ident at the top when it's mounted on the PCB. Let's have a look at the sockets I bought. This was a long time ago. I bought these as well. Same problem, I think. To get the ident at the top, we have the socket upside down. Oh, that's a terrible nuisance. So this isn't in some ways much better than what we have on there. Though of course it is brand new. Right, I'm going to take this board off and make a decision about if I'm going to repair what's on there or fit the new one. I don't know if you can see that. Let me try and get it in focus. There's a little bit of misplacement of this contact here. So the socket is a bit worn. So I think we will have to fit the new socket, but we're going to have to do the same trick of mounting it upside down, which is less than ideal. But maybe I can do a better job than I did some 10 years ago when I didn't have this microscope. I'm going to start by just getting rid of the soldering on these contacts, which took me so long to fit in the first place. Okay, so I've desoldered the remains of the socket, apart from I've left the bit of braiding on there. Hope you can see that. So I'll just check that nothing's gone open circuit. So this time, rather than try to fit that socket with its pins going down to the board, I'm going to solder new wires to the pads to meet the pins. Of course, if you mounted that socket the wrong way around, you would, in good old Firewire fashion, blow everything up. Okay, so I've fitted the socket, and the way I've done it is broadly similar to before, but this time I have connecting wires. So these connecting wires mean that there's no stress on the contacts of the socket going down to the board. So that means even if this did move a little bit, then it won't break the connections to the bottom. But I've again fitted it to the board using a strap of desolder braid, which works really, really well. Makes a very solid connection. Let's look at that under the microscope. You can see the desolder braid, which goes around the socket and is soldered on all the way around, so it's going nowhere. And then all the connections soldered underneath. Right. I'll clean this up with a little bit of isopropyl alcohol because I always like things to look tidy. And then a key thing is whether it will fit into the machine, whether the sockets will line up. I do hope so. There's another reason, you know, that I ran wires up to this rather than using its original connectors on the back and bending them down, and that is that if you do try to use original connections, there's every chance that they will snap off, as these have done, so I ruined that new socket. So here's our key moment. We'll get these connectors out of the way and we'll see if it fits. Oh yes. Oh, that's nice. That's absolutely perfect. So you can see the sockets in there. I can't do much about the fact the cabinet's scratched up around there, but the socket fits really snugly, so I can't see that moving anywhere. So I'll refit the screws for the PCB and then refit the connectors, and we should be able to test it. Okay, I would say that's at least as good as new and possibly a little bit better. And this is the plug that's going to go into that. Good. Let's power it up and test it. Okay, so we'll power it up. We can already tell it's working, I think, because we just heard that beep 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 sound. Switch it on again, because it does that when you first switch on. Import from Sony device and start capture. And that's working perfectly. Good, we fixed it. Okay, having got the machine fully working, I have fabricated a small piece of, well, what I did, I cut the lead off an old diode and soldered, sort of plastic welded and glued it into this corner so that it goes through the hole in the hinge for this end, and this end was still intact. So slid that in there, and now we have a lid that, more or less fits. It's perhaps not as neat as the original would have been, and it needs to open far enough to let the tape out. But that's fine. So yeah, it's not as good as it would have been new. I've done better ones than that. For whatever reason, I didn't get that one placed as finely as I would have liked. But that will certainly do the job. Right, I'll reassemble it and then I'll show you something else that you can do with these things. Right, let me show you another useful feature here. We have a time-based corrector here, which I can output test signals, and that's connected by an S-video cable to the DSR-11, which is set to S-video mode. So if we select test signal, we get the test signal there on the TV. But better still, we can use Pinnacle Studio or your favorite video capture software to capture the video directly. So it's going electrical to electrical mode. You get an input from here and it's going out to DV and to the monitor, and I can prove to you that that's the same signal. So this could be used for capturing from many different, this could be used for capturing from many different formats. I would recommend also including this. So if you're capturing some say VHS or beta, you can get timing errors, and they will cause potentially problems with the DV capture system. It can abort or give you bad results. So if you feed this time-based corrector now with signal from say VHS, beta, V2000, what have you, allow this to feed here, and then with audio as well, this unit handles audio, or you could feed audio directly into here, then you'll capture audio and video to DV-AVI files. One of the great things about using this sort of system is that the resulting DV-AVI files edit really well. You don't tend to get lip sync errors and little blocky artifacts and horrible things like that you would from some other video file formats, especially for example MPEG-2, which you would get if you were to rip to DVD. That's something people do sometimes, is they use a DVD recorder to record something from VHS or beta or what have you, and then rip the DVD, but you're generating MPEG-2 files that are not very well suited to editing. This gives much higher quality results. The difficulty can be getting hold of a digital time-based corrector. There are ways around that. Some Panasonic and maybe other DVD recorders can work in E to E mode with their time-based corrector. So that's one way of possibly getting a time-based corrector solution. But I would always recommend having a time-based corrector before your video capture, unless your machine already has a known very good time-based corrector, such as is included with some Betacam professional studio decks. Right, Let me now show you why that might not work. So let me show you what we have set up now. This is a Sony DSR-11 DVCAM machine that I repaired a little while ago. And there's another model that's extremely closely associated with this. It's a DHR-1000U, which is very, very similar, but is aimed more at the DV rather than DVCAM recordings. So we can use this same software to capture from here. The Firewire port on this model is very unhelpfully only at the front. There should have been one at the front and back, but we start capture and we can see the video on there, and it's capturing to computer at the same time. Perfect, you'd say. And we can have our TPC running through here as well. Let's pop the tape out so there's no confusion with that. So we will be in E to E mode here as well, won't we? Because, come on, close please. We'll be in E to E mode here because we have electrical to electrical out on the monitor there. So we say start capture, and we get nothing because there is apparently no electrical to electrical capture to Firewire on the DSR-30 or DHR-1000, because I've tested that too. And I don't know if there's any other models that might apply to. There's no mention of it in the manual either. So I had plans for this machine. I was going to set this up in my studio so it could be used not only for playing tapes but also for E to E mode for capturing, and it's handy because it's got VU meters and you can see you've got good sound before it's fed into the capture system. And no, I can't do that because for some crazy reason they didn't support that. You know, all the connections, all the equipment, everything's there for them to do that, but for some reason Sony chose not to do E to E, so electrical DV capture on the DSR-30 and DHR-1000. Now I had mentioned that I prefer to use PCs than Apple Macs for DV capture, and there's two reasons, and I'm not just having a go because I tend to be a Windows person and I don't like Apple Macs very much. It's because there are some good reasons. So I would strongly recommend, if you're capturing DV, that you capture to a physical separate drive inside the machine than the one that has the operating system. And certainly the way I do it, and have done it for some years now, is both the operating system drive and the capture drive will both be SSDs, so you don't have problems with seek time and drive startup. So you want two SSDs which are physically separate. That is generally easy to achieve on a PC, in particular a desktop, but I mean laptops can do it too, but in particular a desktop will make it a lot easier then to add the hardware necessary for Firewire capture. Most laptops of either type don't have Firewire ports anymore, and any that do are pretty old, so they won't be able to necessarily keep up with the data rate, which is reasonably high. So I think the best setup is a desktop PC running Windows 10 or 11 with a Firewire capture card installed and SSD boot drive and SSD capture, and then once you've captured it to the SSD you can dump it out to a mechanical hard disk. The reason, so that's difficult for Mac, okay, unless you've got certain models of Mac Pro. In general it's harder to achieve that arrangement. You can't, I don't think it's successful having any kind of interface between the Firewire port and your machine. So if you're going via USB or something else, I don't think that's going to be as reliable as using a proper Firewire card plugged into the PC. And you really want to avoid dropped frames. The whole purpose of all this is that you want it to be able to capture continuously with no dropped frames. So when I run a tape that might be, well in this case up to maybe a couple of hours, but I can run 3-hour tapes, even longer, at the end there are 0 dropped frames. If I get any dropped frames, I'll explain why there's an exception to that, but if I get any dropped frames, then I'll start the tape again for the customer because it's not good enough. Right, the exception being if you're capturing 8mm on a Firewire port that's on a digital 8 camcorder. If there are gaps in the recording on the tape or crash edits, that can give what look like dropped frames, but they're not. They're kind of runt frames, which don't really exist. They're, you know, half a frame, and the capture software will report a dropped frame, but really it wasn't a valid frame in the first place. Right. Software is the other thing. On a PC, there's a whole host of different software for video editing, including video capture. I've been using Pinnacle Studio here, though there's a free piece of software that's very old and isn't supported anymore, but still works, called WinDV, and actually that's rather good. So you can capture happily for hours with no dropped frames. An Apple Mac might be able to do that, but what software are you going to use? iMovie has or had the ability to capture from DV using a Firewire port, but it doesn't report dropped frames. So you can get the situation where you think you've done a good job, and then later when you come to watch it, you find that the motion judders around because it was dropping frames and you didn't even know about it. So I'm afraid I have to say this is a job for a PC desktop, not an Apple Mac. Oh, and I've seen it reported that the Firewire drivers were not included in Windows 11 anymore, and that's just not my experience. I plugged Firewire stuff into Windows 11 and it just worked. So I'm not sure where that came from. It was on Wikipedia. My impression is that Windows 10 and 11 do support Firewire natively. Right, I hope you've enjoyed what we've done here today and maybe learned a few things. I'll do plenty more content on audio and video technology in the near future. Bye for now. Right, I'm going to do a poll and I'm going to ask you guys what you'd like me to do for next week's video. And the options are back to this very rare SLHF100 Beta Hi-Fi duplicator, which we left it in a sort of working condition, but the tracking is off. It might be that it needs new heads, the VU meters aren't working properly, and there's issues with headphone sockets. That's one. The other would be to look at these. These have been dropped off by my sister. A couple of old radios, very old radios. So we have a old Panasonic. I don't know much about this at all, but it's got FM, long wave, medium and short wave. Don't know what's wrong with it, but that's the newer of the two. The other one, now this is something. This was in our family, and I remember this when, right, bit of history. My father was in the RAF and we got posted all over the world, and we at one point were based in Tobruk in what's now Libya. And I remember when I was a very, very young child, I remember this radio. So this is really old. It's branded National, which means it's National Panasonic. It's actually the same make as that, or Matsushita or Matsushita. Never did understand how I was supposed to say that. So this is older than me. This is going to be germanium transistors, I think. Still in its leatherette case thing. Wow, that is old, isn't it? That button, I think, was a light for the dial. I'm sure that won't work. There was an aerial there that's gone, and I don't know what state the actual radio is in. And it's got medium wave and 2 short waves. So that really is a blast from the past. I'm guessing this is going to be early 60s. Right. Would you like me to work on the radios or the Beta Hi-Fi duplicator? I'll put up the poll, and whatever your response is by Sunday evening, I will start on Monday morning, hopefully ready for next week's video.